Okay guys, let's understand how is this sum in chemistry sorted. This cell, this is the cell, E0 cell is 1.10 volts, was allowed to be completely discharged at 298 K. The relative concentration of Zn2 plus to Cu2 plus is this. Options are these. Okay, let's understand how is it to be done. To begin with, this is the cell provided. We know this is anode where oxidation occurs. This is cathode where reduction occurs. Relevant reaction would be zinc plus Cu2 plus giving Zn2 plus and Cu. Zinc solid, copper solid. Alright. So from zinc solid it got converted to Zn2 plus. There's loss of electron, loss of 2 electrons, so oxidation. Whereas in case of copper, Cu2 plus gained 2 electrons and forms Cus, copper solid. Since gained electron, 2 electrons, so reduction. Now it is dealing with 2 electrons, so N is equal to 2. Now, according to Nernst equation, E cell is equal to E0 cell minus 0.0592 over N log of concentration of product upon concentration of reactant to the base 10. The product that we have over here is these. So jot it down. Alright, in the numerator. And the reactant were these. Jot it down in denominator. Alright. So this becomes our cell. So this was our cell. This was our relevant reaction for cell. And this is our relevant Nernst equation for cell. Alright. Furthermore, concentration of solids and pure liquids are taken to be unity. So here we have copper as solid in product and in reactant we had zinc as solid. So this becomes 1. So into which the equation modifies to this. Alright. Got rid of copper, zinc, solid. Alright. Now, cell is completely discharged is what is given. Therefore, E cell is 0. And also provided is E0 cell is 1.1 volt. So, the form that the equation takes is this becomes 0 and this becomes 1.1. So that's what we see over here. Alright. And N already we have put in 2. Alright, because it is exchange of 2 electrons. So till this part, there's no confusion, I presume. Alright, now what happens is, so 1.1 minus 0.059 upon 2. So this was provided in numerical. E0 cell was 1.1. This is exchange of number of electrons. And this is what we got as in product we had copper as solid and in reactant we had zinc as solid, which got the value of unity. So we got this setup. Alright, now here what we do is we just take it there. This part we take it there and this part we leave it here. So we get it this way. Then what we do is this thing goes down, this thing goes up. So we get this. Alright. And ultimately on calculation this gets the value of 37.3. Mind you, this is log of this to the base 10. So let's get to a bit of numerical in terms of log. So we all are aware that whenever we intend to remove log, we have got something like this. What happens? The base, now if it is log y to the base 10 is equal to x. Base comes over here, takes this place and x rises up and log disappears. So that's what we find over here. So what happened? 10 came here and x became the power of 10. So became power of 10. So y is equal to 10 raised to x and log disappeared. Similarly, if we want to bring in log, what do we do? Now suppose this is where we have got to bring in log. So what happens? Reverse process. X comes down, 10 goes down as base and log appears. So log y to the base 10 is equal to x. I hope this small recovery that we did for log would be helpful. Alright, okay, so that's what we do over here. So what happens over here? This thing, so this, assume this to be our y. Alright, so 10 comes up, 37.3 goes up. So log disappears. So that's what we do. And this is the value that we get. And the answer is D. Okay, I hope it's clear. Okay.